Society for having us here today. It's a real honor and a great pleasure to be here, and thank you everyone for coming out and showing your interest in what we do. So I'm going to be telling you about Air Race E, and to tell you about Air Race E, sorry, is this working if I go over here? Okay, there we go, that's good. So to tell you about Air Race E, I think it's important to tell you about what's going on now and what we're currently doing in air racing. So before I get to the first electric airplane race, I'm going to tell you about this form of air racing. So it's Air Race 1. It's actually a form of sport called Formula One air racing. Now this is conventional racing, so what we're doing is we're taking conventional airplane racing, which I'll tell you more about in a moment, and just moving it into the next generation. Now before I tell you more about it, I figure it's often easier to show you a little bit more, to give you a bit of a flavor of the sport that we do. So this is currently what we're doing now.
You know there ain't another girl like her in the city. No, you know she looks so good, but she ain't so pretty.
Okay, so that's the Air Race 1 World Cup. So as you can see, this is multiple planes racing against each other. So this is actually the only international air race in the world where multiple airplanes race directly against each other. Many of you here have probably heard about, of course, you know, the Reno air races in the US. We race there as well, the same sort of air racing, but that's a national US championship. Obviously, you're familiar with the Red Bull Air Race, which does a fantastic event, but that's single plane time trials. So we have airplanes, 8 airplanes that take off from the runway at the same time, drop the green flag, they take off, climb to about 10 or 20 meters, race 8 laps, first one across the finish line wins. So it's pure motorsport, true racing, and it is very much motorsport. We position it very much as a motorsport first. So we're getting this the media reach, so we're having a very, very excellent footprint now in the global reach of the audience. We get tens of thousands of spectators to these events. We also have over 1 billion people have seen the media and the news and the press releases and the coverage on print. We are broadcast on television in over 100 countries, 120 countries. We're on Sky Sports here, and the BBC often covers us as well. So we're really getting it out there now. But I say this is what we're doing currently. Obviously, air racing has a long history, and I think everyone in this room probably has at least as much, if not more, familiarity with some of the history of air racing than I do. Air racing started, of course, in France over 100 years ago, and our sport, Formula One air racing, started over 70 years ago. So it actually started in 1947, and it came from a form of sport called midget air racing, so it actually has a heritage even before that. But Formula One air racing has been governed by the same governing bodies for 70 years. So a group of people got together, started an association, started a set of rules, and those rules have been governed and run and tested and changed and adapted, and races have been run for over 70 years now. And we work with that. Actually, these are the 3 associations that govern the sport. So the first one that founded the sport is the International Formula One Air Racing Association, based in the US. FARA, which is the Formula Air Racing Association, that's based here and is a member of the Royal Aero Club, that's the British body, and APAF, which is the French body for Formula One air racing. So these 3 associations are the 3 governing bodies in the world, and they sanction our events. They sanction the Air Race 1 events, they make sure the events are run safely, and they help us run the races. The pilots come from all over the world, an amazing group of people. Maybe over half the pilots are North American. Most of the rest are European. We've got a lot of amazing pilots in the UK here. So some really great pilots that have raced in our races for us. And we know there's at least another couple dozen that are ready to go to join Air Race E, which we'll come on to in a moment. You can see a little bit of an example of the circuit here. It's just 6 pylons and an oval circuit. So again, our race is all about speed. It's a race, proper race, that's what it's focused on. Just another quick indication of the media footprint. What we're really pleased with is that we're not just reaching out to kind of aviation geeks like us. This is not just enthusiasts. This is a mainstream audience that we're appealing to. So we are actually reaching out to audiences, lifestyle audiences, other sports audiences. We're reaching millions and millions of people with air racing. So this is a fantastic platform to be able to communicate, obviously, technology and the thrill of racing. All right, so this is a video that is going to just show, kind of peel back another layer of air racing. It's a little bit more technicals from the pilot's perspective. Talks a little bit about what they do to prepare for races.
The biggest challenge is always to try to keep your airplane running. You see, it's not just a sprint, it's also a marathon. We have 3 heat races to go through, and they are very grueling. You know, 8 laps each, that's a long time to keep an engine running at such high performance.
Many of these planes, if not most of these planes, are actually built by the pilots and an engineering crew, so they're all very unique airplanes. They're built specifically to fit the pilot, to fit his racing style, and they all have their different technical differences and their secrets and their tricks, but they're all built to a formula. So that's where, of course, it comes from the name Formula One, which has been used for about 70 years in the sport.
The engineers are just as competitive at trying to design the fastest airframe to go with the same engine as everyone else, and as you can see, there's huge variety, and the competition really does breed all sorts of inventions, so it's a fantastic place for innovation and competition.
Have the same engine, which is a Continental O200, so you can tweak it but just a little bit, so every pilot has pretty much about the same power.
There's a minimal wing area, so the wing has to be a certain size, a minimal size. We have to have landing gear that does not retract, and the propeller cannot change the pitch of the blades or change the angle of the blades. And we have a minimum empty weight. There's a lot of different designs. No 2 airplane looks the same. You get to see everybody's ideas and their theories on what they think goes fast. So you see a lot of creativity out here.
You gotta have an excellent airframe, an excellent engine, and an excellent pilot. If you don't have all 3, if you're lacking in any one of those categories, you are not gonna win.
There is a lot that goes behind the scenes. The pilots will come to us and they're always after that extra knot, another mile an hour, another 2 miles an hour. And there are quite a few parameters, and there's certain things we can do to the engine just to get that extra little mile an hour.
It's kind of like being a doctor. You want to do no harm and change one thing at a time so that you get a good development process going.
And what we've done is build a new carbon deck, the whole back end of the aeroplane. Originally the cowling was a lot shorter. We put a 12-inch prop extension here to push the front of the propeller forwards and changes the shape of the cowling, make it more aerodynamic.
You don't often get in my day or my sort of normal work to look at 10 aircraft that we did that have to go together in a short space of time, and it's a great challenge.
It really is a hotbed right now of development in any class. It's exciting.
The mechanics here are really expert at fixing problems that crop up and getting ready for the next race.
You're constantly taking things apart and looking at it, improving it, whether it may be changing a prop or checking, seeing if anything's scraping or touching, checking tie wires, make sure they're tight.
Tweak a little inlet or put a little piece of tape here or run the electrical wire this way.
Another change, the wheel pants 4 or 5 miles an hour, the intake, the extension.
These airplanes, the fast ones, will have revolutions in the neighborhood of 4,000 revolutions per minute. So that's almost twice as much as what they're designed for. So as you can imagine, they are pushing the limits. They are trying, the engines are trying to blow themselves apart, and occasionally some do.
If the engine gets blown and we can find a spare, we'll work right through the night to put it in.
At 7 o'clock, 8 o'clock, 10 o'clock, 2 in the morning.
2 nights ago, Kevin was sleeping under the wing. Roy was on the couch, and Ben was on the other couch. I mean, they pull all-nighters. They get up at 3 a.m. if they need to, maybe do engine runs on a different airfield to check the mods.
If you need a tool, we're going to give it to you, and if you need some parts, we're going to give it to you. Even if you need one of our men, if we can spare them, we'll do it. We want everybody to race out there.
Open the box, hand him the carburetor. Other people trading back and forth. Somebody's missing a prop. They cracked a prop.
Tearing engines down, putting them together, building new cowlings, fiberglass work, wheel pants. They can practically build an airplane overnight.
We really are pushing these things. We're trying things that are on the limit of what we're allowed to do, and you just don't get that. You just don't get to do that at home.
Everyone's trying every little trick in the book they can, and everything they can do to get their plane ready. So really, there's no telling who's the one who's going to pull the rabbit out of the hat.
Okay, so hopefully you found that interesting. I've seen that video countless times, and every single time I could watch it over and over again. I love listening to our pilots and our engineers talking about what they do, and it's just so joyful to hear. You know, I mean, all of it's over my head. I should have probably caveated my presence here before I started speaking, which is saying I'm not an engineer. I couldn't build an airplane for the life of me. I can maybe turn a screw, but I bring together all these people that can really bring that to life. You probably recognize a number of people there. I'm sure most of you have spotted some familiar faces. I should have also mentioned earlier that we've raced, you'll see the imagery that we've had there. We've raced in China, we've raced in Thailand a couple times, we've raced in Spain a couple times, Tunisia, the US of course, and elsewhere. So this is a sport that's really, really growing. But the real exciting part, and the part that you're here to hear about, of course, is the Air Race East. So this, how do we take it forward? So that's got these years and decades in life and the hundreds of thousands of stories behind us, but how do we take it into the next generation? So by starting the world's first electric airplane championship, we hope to create what we kind of refer to as a unifying platform. So the idea is that this event is going to be open to all people, all manufacturers, all builders, all service providers, all technology companies, all pilots. Anyone who wants to build a plane to the rules, which I'll explain more about as well, can come out and join us. So this is an open event, and we expect everyone to come and take a share, take a stake in the project. It's a global platform, so even though our roots are more or less kind of starting here in the UK, it's very much a global proposition. So this is going to be absolutely international. The events are going to be around the world. We're going to be meeting with partners all around the world. And the teams, of course, will be coming from all around the world. And as I mentioned already, it's based on Formula One air racing. So we're really taking that as a benchmark, including the rules and the principles and everything, which I'll explain on the next slide, and just switching out the powertrain effectively. It's not quite so simple, of course, but that's the concept. So this slide kind of talks about really why we're positioned to be able to do this. And we believe we're actually, sounds a bit bold, but the only organization in the world that really can deliver this race. The reason is because we already have everything in place from those events you just saw us showcase in the videos. So we work with the Formula air racing associations. So the associations that run the sport, govern it, make it safe. We have the pilots, the planes, the engineers, the ground crews. So all of these components, all these ingredients are under one roof. We have the venues, of course, the media, the PR. And of course, a lot of other organizations have lots of those things, but by being really the only group that's brought the actual competitive kind of wingtip to wingtip racing around the world, we realized, hey, wait a second, we have an opportunity here to be the first to market, to really, convert this into, as we said, the next phase, the next evolution of our sport. But of course, we're just missing one thing, which admittedly is a bit important. It's the actual powertrain. So the electric powertrains is what we're looking for. But this is what's exciting about it, is that we can bring everything else in the package to the table, and now we're just looking for the manufacturers to come on board, and that's actually really our customer. That's the partners. So it's not something we're missing. It's something we're creating a platform for that, to invite them to come in and develop the teams. And they are showing a huge amount of interest. We've actually got, you were introduced to one a moment ago. I'll call him up in a few minutes. Richard Glassick from the University of Nottingham. They've come on board here. I don't know how many of you have checked the news today, but we just announced today, so this is the first sort of occasion I can actually say it out loud and say it to people. We just signed a partnership with Airbus. So Airbus has just come on board as a founding partner of the series. So the manufacturers and the technology companies are indeed coming. We have a number of others in the works that you'll hear about in the coming months. So it's a really exciting time. But they seem to be attracted to this, and it seems to be working. So why? Why would they get involved? Why do we want to do it? I mean, the current racing we do, conventional racing, the Formula One racing, is really very much about the fans, about audiences. It's about thrilling and entertaining, and the pilots, of course, the participants, the competitors really enjoy it. But for Air Race E, it's very much about the technology companies. So it's really very much geared towards the manufacturers. So they're our clients, but they're kind of the purpose of doing this, if you will. So we need to offer them something, of course, and needs to be interesting for them to be able to get something back out of. So these are just a few, sort of snippets of what we think we offer to the manufacturers that want to submit teams to the series. Of course, by being a global property, we're offering access to new markets, showcasing themselves in new venues and new cities around the world, and being able to communicate what they're doing and the technologies they're developing as well to the wider world. Building relationships. This is kind of the most interesting thing, I think, that all of them have said as they come on board and talk to us and express their interest. They want to not just see what everyone else is doing, but actually work with other manufacturers. There seems to be a really massive sort of collaborative, kind of motivation to everyone coming on board. So they all want to meet each other. I don't know how much they'll share in the technical details about what each other are up to, but they all want to be at the same place in this unifying platform to develop their technologies. So this is great. So we announced this a little less than a year ago. And I think the timing is really important. So I think, we all know that there's it's a revolution coming in electric power, electric propulsion. We've all seen it. We all know the importance, or you wouldn't be here today. So I think that's pretty clear. And of course, if you talk to anyone in the industry, we're talking about maybe 20, maybe 40 years away down the road before an airplane can be, take this group for example, 100, 200 people to any meaningful distance with electric propulsion. It's a long way off, and we keep talking about it being off in the distance. But the technology that allows us to air race, to do what we want to do, is here today. So it's actually here now. And the exciting thing for us is that we are absolutely convinced that when you're taking that flight 20 years from now in some commercial electric-powered jet, well, not jet, forgive me, electric-powered plane, you're going to be able to trace the roots of that technology back to what we're doing now and the participants in the series that are able to test their technologies. So we really see a path from here to there by offering this race. This is important too. So in all the development that's going on right now, there's a lot of development. I think we're all aware of all the different projects that are out there. Some are flying, a lot of them are yet to fly. What we offer in an air race is this real world environment. So a race is a mission, it's an objective. You can be successful or not. You compete in it. You've got all the other teams that may be successful and you're not. whatever. It's an objective, it's a mission. And so we're giving, and that's real world. So there's a real task, and you have to achieve it, and you have to be the best at it. And so we're actually able to test all these technologies and the different, even services and charging and all the different, pieces of the puzzle, are able to test it in a real world environment. It's not just that, let's just send a plane off, go to point A, come back, tell us how that was. This is a real world actual situation. And it has to be relevant. So I mentioned we're doing this really with very much the manufacturers in mind, with the OEMs as kind of a customer almost. So it has to be relevant to the technology they would develop in the air race or put into the air race would have to clearly be relevant to applications in the market that they want to develop later. So products, services they want to sell later on. So we very much have to keep that in mind, and we're going to be, we take on board with them their contribution. We want a kind of a holistic approach to, and a collective approach to writing the rules and developing the series so that it goes in a direction that's relevant to where they see the market going. So it's very much an iterative process, going back and forth between how we see an exciting air race, but being relevant to the people that are going to be actually submitting the teams. So obviously a key message for us is sustainability, clearly. Bringing electric power to the market, but it has to be sustainable financially and economically as well. The great thing about the airplanes that we use is that they're home-built airplanes. These are experimental class. Well, in the U.S. they're experimental. Here, permit to fly, but we've got a new experimental class, which the LAA is working on, which is going to be relevant to these planes. But the idea is that they are they're simple structures, simple platforms that are very malleable. You can, change the engineering of them all. I guess what I'm saying, this is where it'll showcase my lack of knowledge, because I was about to say, they weld the planes together and you can have a plane. That's about as much as I understand about building a plane. But these are, you don't have kits. These aren't planes that you buy. These aren't planes that that come in a kit. You put them together. These guys manufacture. They fabricate these aircraft from plans that are perhaps in a CAD drawing or on the back of a napkin that they designed themselves in and brought it to fruition. So the great thing about this platform is that they're adaptable. So we're taking, again, the same aircraft that already exist in Formula One air racing and just retrofitting them and shaping them to start the race. Now, of course, as we go forward with electric racing, all of these things will be open up, and the airframe and everything else will also be able to be completely adapted. So how to do that? You do that in a formula. These are the racing rules. It's an electric formula called Air Race E. The rules are going to be governed by FARA. So those other associations are very much involved, but FARA, the British association, is really going to be the global sanctioning body for the sport. So the Formula Air Racing Association, member of the Royal Aero Club, which was also a member of the founding member of the World Air Sports Federation, is going to be governing the sport. So we're developing the rules, and of course, FARA is involved with that. Pulled out just a few general points here to give you a bit of an idea about how the rules will apply. The first point there really just talks about what I've mentioned a few times, which is the Formula One basics. So as you heard some of the pilots talking about in the video, it means 66 square foot of wing area, 500-pound minimum weight, fixed landing gear. And we have about 30 pages of technical documentation, which tells you how to build a Formula One plane. We're taking that and actually referring to that, those are the rules. And then we have a separate set of rules, which is contrasting, of course, what's different, based purely on the propulsion system. And we're going to limit it to 150 kilowatt power. It's a really interesting kind of sweet spot across not just aviation, but across other industries as well, motorcycles, cars, and other applications. That is actually going to be more powerful than the current motor that we have in the airplanes. As you might have heard somebody say in the video, we use a 100 horsepower engine, but because of the propeller they put on it and the things they do, the modifications they make, they can get even up to 200 horsepower at sea level out of 100 horsepower, Continental 0200. So we need to really actually mimic, if we want to equal the performance, we have to get up to that level, the actual applied level. and we think this is actually going to go further. So we very much expect these planes to be even faster than the current planes. I mentioned a boost there. It's kind of a cool idea that actually came out of the University of Nottingham, which is, when we race, Formula One racing, unlike most other motorsports where you're always adjusting the power, going around chicanes, in airplane racing, in our form, it's full throttle, and that's it. You're full throttle for the whole race. There's no reason to go off the throttle. So you're constantly at full speed, or at least full power. And we wanted to throw something else into the mix. So for one lap during the race, you're able to press a button, turn a dial. We're going to work out the ergonomics of it. But to get a boost, to go up to 175 kilowatts. So that should create some competition excitement, but also, again, having relevance to the developers that want to know how to manage power. It's going to be a 5-lap race. Formula One currently is 8-lap race, so we're shortening it just to make sure everything is going to be focused. Obviously, it's going to be long enough to make an exciting race. It's going to be about 5 minutes long. And then they have to have enough to come back and land, which makes me maybe skip to that next point at the bottom right. We started thinking, how much of a charge should we allow? Should we have them charge it to 25 kilowatt hours? What do we do? A cap, a maximum, minimum? As we're developing the rules, we're trying to figure this out. And then we thought, actually, well, why not just let them decide that? Let them come up with a configuration, the specifications that work for them. But of course, what we don't want is people coming, calculating it too finely, not having enough power to land. So another cool innovation and idea from the University of Nottingham is, well, let's have a backup battery that basically gets turned on, gets integrated only if the power goes to a certain low level in the main battery. And so the idea is that of course will get them back to the ground, but if that clicks over and they go to the reserve battery before they cross the finish line or some point that will be determined, they're disqualified. So there's still a penalty, big penalty. They still have to manage it, but it's not a safety issue. So we've got quite a lot of rules that have these types of provisions in them, which are really exciting and also, of course, geared to make it as safe as possible. Last thing I'll mention on the rules is multiple motors. We don't mind if it's 1, 2, 3 motors in line, stack them together. You can have contra-rotating propellers. That's fine. The only thing is that we want them kind of all in one sort of axis, so it's not like 6 different motors, not like a multi-engine, in fact, even though there'd be multi-motor, but sort of aesthetically, if you will. It's got to look kind of like the current race planes. But this opens up, and even the wings, 66 square foot wing area, could be 2 wings. I mean, there's a lot of other ways we can approach the situation. This is our big message. So this is what we want to, I've said it already, but this is the big point is everyone's welcome. We want to attract manufacturers and teams. Since we announced this project, I've had dozens and dozens and dozens of people contacting us, home builders, just private people as well as organizations, but also private people just saying, hey, we want to build a team. We want to build a plane. How do we enter this race? So we're going to be issuing the rules that I just talked about very soon over the coming weeks. And the idea is that we want to invite everyone, as long as they're safe and qualified. They'd have to go through a race qualification course, et cetera, et cetera. But if they can build a plane to the rules, we welcome them. And we're also going to be doing some matchmaking. So we're going to be talking to manufacturers, pilots, teams, engineers, owners, sponsors, and trying to bring them all together and put them into a team so that we can actually matchmake and find the right teams based on their criteria. There's a long list of criteria. And this isn't just speculation. So everything I'm talking about is actually happening now. So we have this partnership with the University of Nottingham. And we actually have this plane, which is a Formula One spec plane, sitting in the shop at the university right now, which is being converted to electric power. So this is going to be the first electric race plane. And we're going to use this, of course, we're using it to validate the rules and prove this particular model is a Cassette 3M, make sure it's a safe and reliable platform for air racing. And we're doing that. There's a lot of exciting things, which I think my colleague Richard might get into. So I'll use that moment to actually invite Richard up. Richard Glassick here, yeah, come on up, is going to take over. He's going to bring you through some of the slides, talk about the work that they do. And then I guess we both will be up here for questions and an answer. So, yeah. Well,
thank you very much, Jeff.
no worries. Right.
Well, and thank you very much for coming along, and it's a pleasure to speak to you. I do recognise some of the faces. So, yeah, my name is Richard Glustick, and I currently work at the University of Nottingham as a research fellow in hybrid and electric propulsion. I've been there for about 2.5 years, and I've been basically studying and working and researching in aircraft, and in particular hybrid electric propulsion, for at least 15 years. And so in my role as a research fellow, and we do a lot of academic research, and the university is very, very powerful in electric and machine control and drives. That's been our forte for a lot of years. Recently, we've been getting more into aviation because aviation is becoming more electric. So there's a lot of projects that we do with Clean Skies and other organisations in electric propulsion and more electric aircraft. And last year, the university decided to invest some real money internally to drive our research forward across a number of themes, and one of the themes happens to be propulsion and electric propulsion. So when the opportunity came along, and I saw what Jeff was doing, AirAce, and I had this role to develop an electric demonstrator platform for the university, something that would actually fly and work. Well, it was a very easy match to make, and I got in touch with Jeff, and we discussed it, and we realised we were on the same path, and we want to do the same things. So, in the end, we got together, and we formed a partnership whereby we will develop one of his airplanes according to the requirements of the competition. He's just explained very well. So here's a picture of Jeff's actual own airplane being delivered to Tollerton Airport in Nottingham just last year. And so that's now the platform that we're working on to develop this demonstrator, which is going to baseline and benchmark the kinds of technologies and components that need to go in to the race class to be able to provide a source of information for the competition class, the rules and regulations, and also the builders and anyone else who's taking an interest, and also for us to showcase our electrical propulsion and electrical drives, electrical motor technology and research capacity. And then the future developments will be, we'll develop bespoke systems for this class of aircraft. It turns out that, in fact, the size and power and weight that is applicable to AirAce happens to be really, really useful, 150 kilowatts and around there, really useful for all kinds of other industrial applications and aerospace applications. Such as, and you would have heard about all of the eVTOL stuff that's sort of sweeping all of the world's media and research capacity, and all the big aero players are into that now. It also brings in our other capabilities in the university. So this picture here on the right is the aircraft in our lab, and one of my jobs is obviously to figure out how to install the electrical components into the aircraft. We take the engine out. And here we have our Institute of Manufacturing doing a laser scan of the cowling of the aircraft, there's a video coming up which I'll detail more about that later. The other key factor that we had going for us at Nottingham to do this project is our electric race bike program. And this has been going for about 5 years or more. It's been very successful. This is maybe last year's bike or the year before. All done in-house in Nottingham. Even the frame and the mechanicals are designed there, but in particular the electrical propulsion system for this electric bike, which has succeeded very, very well at places like the Isle of Man, the TT race Isle of Man, and others around the world. And so we've got this base, and it turns out that the size and the power and the weight of this machine happens to suit the Air Race 1 type aircraft really well. So we've got this background of experience of people in the lab putting together this kind of electrical propulsion system, which happens to suit the size, power and weight required for the aircraft. So that's a really good basis to go on, and we've got the in-house capacity to do that. And we're not robbing from the bike. I mean, the bike program's going ahead. You'll see all this stuff this year, the latest bike. I think last year at Isle of Man, we came second. We came second to Honda. Honda has a budget about maybe 100 times our budget, so we do pretty well. Okay, so some pictures of the airplane in the lab. We've done some weight and balance work. We're pulling the original propulsion system out. There goes the engine. We're putting a new propulsion system in. We want the airplane to basically be, in terms of its performance and obviously its mass and balance, to be pretty well the same as what came out, because we want to baseline and benchmark that performance capability first. And so we've got our facilities in the lab to do that. This is some detail of the scanning, and the video is just coming up, but this is a laser scanning system where we can basically take the geometrical data directly off the aircraft into a CAD system. And it can even be done using clever robotics to drive the laser around the object that we're trying to scan. This is video. So this was actually, we did this obviously for promotional purposes, but this is when the aircraft was delivered basically last year. We can apply the highest level cutting edge research in electrical propulsion systems to any transport domain, but in particular aircraft. Currently there's no electric racing aircraft program that's running in the world.
As fossil fuels become more expensive and more difficult to obtain, then electric motors and electric propulsion will become more important. We want many teams to use this unit, so it needs to be interchangeable on many aircraft.
And so this particular aircraft that we're working on now represents the sort of technology which can be adapted towards those much larger commercial aircraft. Yes, so it's quite exciting, and we've got great people to work with. Just Network, and you can see the pilot, the crew chief, and everyone who's come along to help us. We feel very comfortable with that. This is going to be a video of the scanning process. So we're trying to bring in the rest of the university. There's a lot of technology going on. There's materials, there's manufacturing, there's other production processes. And this is one of them that's key. We've got a very big investment in the Manufacturing Institute at the university at the moment. And, oh yes. So, screenshots. The lasers passed over the physical object. There's a camera system, stereographic camera system, which can pick up the line, the laser line, as it passes over the contours of the object, and it goes straight into CAD. And that makes my job really simple, and because I've now got a CAD model, and I've got to fit where the batteries go, is there enough space, you know, just the spatial location of the new propulsion components. So our manufacturing crew were super valuable for that. And again, with the propeller, it's of use. I mean, there's a whole range of different propellers we could use, but it's of use to get a model of this propeller, which came with the aircraft. And this is showing you the robotic application of that technology. How cool the way it is, I just want to get it. And so we're already being very successful at the moment. This program is working well in the university. It's bringing together our different research arms and coordinating them, and for very useful results. And it's definitely helping me in my job for putting together the electric racer. It's great for publicity, of course. This was a big opening of our Manufacturing Institute, where the very top guy from Siemens came along, and this was a major part of the show. So we're very happy with that. And this is, you know, just the current iteration of the propulsion system as it's going to be installed in the cassette. Most of the airplane remains unmodified, practically a firewall forward installation. There's a number of features that we're going to integrate which enable us to go forward. We're not trying to, we want a very flexible design. We want something that we can work different types of motors, direct drive motors, geared motors, and we want to maintain the overall size and shape of the aeroplane fairly closely. So currently this is a mechanical integration side. We're also doing concurrently the electrical design integration, and it's progressing quite well, and we really want to fly this thing, of course, this year and then hopefully during summer. So It's just ongoing work, electrical system design. We've got to procure various components. Some of the components are in-house designed and developed. Some of them are going to be, certainly in the first case, commercial off-the-shelf components. We intend to develop a complete power electronics and motor drive system in-house, and we can do that and we can build it. But to start with, to get this thing flying as soon as we can, we'll be integrating commercial components. The mechanical system design, and of course we're working with the airworthiness side of things as well, and we've got good partners to work with, and we've got a very good environment to work with at the moment in the UK. We've got E-conditions, we've got the LAA, and we've got all of this body of knowledge in the industry. And so that about wraps up for me, and I'm glad to see that there's plenty of time for questions. So please hit hard.
Perhaps I could